Hi, welcome to part 6 of the video series about work and energy. In previous videos, we learned about work and how to calculate the work done on an object by individual forces and all forces combined. In this video, we are going to learn about energy. While defining work, we said that the meaning of work differs in everyday life and in physics. However, there is one major similarity between the work in both areas. We can't work unless we have energy. The capacity or ability of something to do work is defined as its energy. An object's energy is a scalar quantity since it has no direction. The unit of energy is joules, as is the unit of work. The uppercase letter E is generally used to describe energy. There are various forms of energies, such as heat energy, sound energy, nuclear energy, and so on. However, we will only cover two of them in this topic. Kinetic energy is the energy of an object as a result of its motion, while potential energy is the energy of an object as a result of its position. There are several types of potential energy, such as elastic potential energy and electrostatic potential energy. We will just be dealing with the gravitational potential energy in this topic. Kinetic energy is determined by an object's velocity and can be calculated as 1/2 times the object's mass multiplied by the square of its velocity. Gravitational potential energy is proportional to an object's height and can be calculated as the product of the object's mass, gravitational acceleration, and height. An object can have both of these types of energies at the same time. Mechanical energy is used to express the combination of these two in an object. Mechanical energy is the sum of an object's kinetic and potential energies. We can solve a simple example to see all the information we learned today in an action. Calculate the total mechanical energy for a ball of mass 2 kgs, which has a velocity of 20 meters per second and is 4 meters above the ground. Let's draw the diagram first before we start solving the example. Since the velocity was not indicated in the example, we assumed it was to the right in this diagram. However, we could draw it in any direction as it will have no effect on the solution. Mechanical energy, as we know, is the sum of kinetic and potential energies. In an exam, you can perform all of your calculations on a single line. However, for clarity and explanation, we will perform each calculation on its own line. Kinetic energy is 1/2 times m times square of v. Mass is 2 kgs and velocity is 20 meters per second. Kinetic energy is equal to 400 joules. Gravitational potential energy is mass times gravitational acceleration times height of an object. M is 2 kilograms, G is equal to 9.8, and H is 4 meters. Their product is equal to 78.4 joules. Now we can add these two values to calculate the mechanical energy. 400 plus 78.4 is equal to 478.4 joules. We learned about energy and its various types in this video. In the following one, we will learn about conservation of mechanical energy. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.